Our next lecture is on multiplication and division of radical expressions. So let's look at an example like this. So if we want to multiply radical expressions together, then what we should do first is simplify things so we can combine them, right? So if I happen to have a root 2 out of this root 6, then I can multiply root 2 and root 2 to get just a 2. So could we do that? Well, we could definitely break up root 6 as 3 times 2, and then we could break that up as root 3, root 2, root 2. And then now you see you can either jump right to the solution, which is that these two would combine and just give us a 2. So we could write that also as 2 root 3, which is more standard since we're putting the non-root expression in front of the root. Or we could write this as, root 2 squared, and then you have that property that would give you the exact same answer in the end, which is 2, and that's 2 root 3. Okay? Two different ways that you could simplify that. Okay, how about this one? So here, root 5 and root 7, we're not going to be able to decompose them in the current form. So what would we do then? Well, we could write this, we can multiply the coefficients together to get 6, right? 2 times 3. And we'd have root 5, root 7. And you can combine to get root 5 times 7, right? And what would this be? This would be root 35, okay? Now, this would be probably better because the only factors of 35 are 5 and 7, right? Those being prime, and neither of those are perfect squares. So this would be an acceptable answer. All right, now how about this one? So 4 times 2 times 5, we can kind of multiply the coefficients, 4 times 2 times 5, and then we can multiply the radicals, right? Unless you already start to notice some of the common factors. Well, I definitely know that I can get a factor of 3 out of the 2 and the 15, the 21 and the 15, so that'll probably introduce another 3. And then out of the 35, well, we could do 7 and 5, and that might give us, the extra 5 over here. So what I'm just getting at here is first factor what's under the roots to see if you can get a perfect square out of it. Or if you don't get a perfect square, if you get enough of the roots, then you can combine those and simplify. Okay, so we have 4 times 2 times 5, so that's 8 times 5, so this is 40. But then what can we do with the 35? We can write that as root 5 times 7 under the root, right? And then 21 is 3 and a 7. And the 15, the 3 and the 5. So here's what I was getting at here. Look at the factorization. None of these are perfect squares, so by themselves they don't simplify, but look what happens when we break this up. So we have 40, then we have root 5, root 7, root 3, root 7, root 3, root 5, right? So look at what we have here. So, whoops. Okay, so down here we have a root 5 and a root 5, so those will combine to give us a 5, right? So what we have is 40 and then we'll have root 5. Well, you have root 5 squared, but you could skip that step and just go to times 5 if you want. Okay, but continuing, we have a root 7 and a root 7, so that becomes root 7 squared, which will give us a factor of 7. And then we have a root 3 and a root 3, right? So that's root 3 squared, so that's going to give us a 3. And then we just multiply all these things and simplify, and that's 4,200. Okay, so all right. So our next example, we have root 2 times this expression, so let's distribute in the root 2. So root 2 times this, and now we can combine like terms together. So see, this one would be 5 root 2 times 3 root 6, and then 2 times 2. Root 2 times root 2 is 2, so 2 times 4. So this would be 5 root 6 plus 8. And there's no more simplification we could do for this one. And then this expression, what we're going to have to do is distributive property. We'll have to FOIL this out. So we will have our first. So first will be root 5 times 3 root 5. And then we'll have root 5 times this term. So 2 root 2. And then, so first outside, inside will be negative root 2 times 3 root 5, and then the last terms will be negative root 2 times 2 root 2. And now we could just simplify these multiplications like we did before. So this root 5 is 5, so 5 times 3, 15. These two we won't be able to simplify anymore, so we would just write that as root 10, so 5 times 2. And then this will be minus 3, root 2, root 5 will be root 10. And then this one, the root 2 times root 2 will be 2, so this will be minus 2 times 2. So now this is 15. And then these two can be combined to give us minus root 10. And then that will be minus 4. So then finally 15 minus 4, 11 minus root 10. And we're done because 10 doesn't have a factor that's a perfect square. Okay, so for this next one, we're going to have to do the same thing. We have two binomial terms, right? So we'll use FOIL, right? So first we'll have root x times root x. Outside we'll have root x times 2. And then inside we'll have 4 root x. And then the last terms will be 4 times 2, which is 8. Okay, so then these two combine to give us x. And then we have 2 root x, 4 root x, plus 8. And then these two we can combine by coefficients, so we'll have x plus 6 root x plus 8, right? The next one, we can rewrite this square as root 5 minus 2 times root 5 minus 2. And we'll use our FOILing procedure, so root 5, root 5. Outside will be minus 2 root 5, and then the inside will be minus 2 root 5. And the last term, minus 2 will be plus 4. So root 5 is 5. These two will give us minus 4 root 5, combining by coefficients because we have like terms of root 5, and then plus 4. So then this will be 9 minus 4 root 5. And this one, we'll do the same thing. So FOIL, right, so root A, and then plus root A times minus 5, and then 5 root A, and then 5 minus 5 will be minus 25. So this will be a squared, or not a squared, just a, right? So up here, you know how we had root 5 gives us 5, and root x gives us x. We'll have the same thing here. So root A is just going to give us a, right? Whoops. And this is minus 5 root a plus 5 root a. So these are going to cancel, right? They're just negatives of each other, minus 25. So this is a minus 25. Okay, so doing the same thing for this one, two binomial terms we will multiply, right? So 3 times 3 is 9, and then plus 3 root x, and then minus 3 root x, and then minus root x, which will just give us an x. So this will be 9, and the 3 minus, so these two are negatives, so they cancel, and then this will be minus x. Okay, so now when we have quotients like this, the trick to simplifying is to multiply by the conjugate. So the conjugate term in this situation is the following. So we're going to multiply by 1, right? We want to get rid of these roots. Okay, so we're going to multiply by the conjugate of the denominator, which is root 5 minus root 3. Okay, and you'll see why in just a second why this is a good choice, but you just are going to negate whatever happens to be here. Okay, so now if we multiply the numerator, this will be root 5 times root 5 minus root 3, and in the bottom we will FOIL these, right? So this will be root 5 plus root 3 times root 5 minus root 3. Okay, so distributing this in, we're going to have root 5 times root 5 is actually 5, and then root 5 times minus root 3 is minus root 15. And in the denominator, we're going to do first root 5 times root 5 is 5. Root 5 minus this, so that's minus root 15. And then we'll have plus root 15. And then we'll have minus root 3 is 3. So you see that these cancel, they're negatives of each other. And so we have 5 minus root 15 divided by 5 minus 3 is 2. So you see we actually rationalize this. And the trick, again, was to multiply by the conjugate over the conjugate. So we're multiplying by 1, we're not changing anything. But that's the way that this method works. All right, so this one, we will do the same trick. We have root in the bottom, right? We want to rationalize this. So we're going to multiply this whole thing by 1, and we're going to take the conjugate at the bottom, which is root x minus 2. So if I'm multiplying by 1, I have to put the same thing in the numerator, and then now we'll multiply. So this will be root x minus 2, and then the denominator will be root x plus 2, root x minus 2, and the top will distribute root x is x, root x minus 2 is minus 2 root x, the denominator root x is x, and root x. See, the reason that you're multiplying by the conjugate is you're not going to have any middle terms. So in the end, we're actually just going to get the minus 4. But if you want to work out the intermediate steps, that's perfectly fine. So this would be minus 2 root x, and then plus 2 root x, and then 2 minus 2 will be minus 4. So you see these cancel. There's no middle terms. So we have x minus 2 root x over x minus 4. And we can't reduce this anymore. And so our last example here, we have root 11 plus root 3 over root 11 minus 3. So if we want to rationalize, we're going to multiply by 1. But what is the conjugate for the denominator now? Now this is root 11 plus 3. Okay, so you just do the opposite sign for that second term. And the reason for that is because when we FOIL this out, there's not going to be any middle terms. So I have to multiply the top by the same thing. So this is 1, right? And then doing this multiplication, we will FOIL both the numerator and denominator separately. Okay. Okay, so root 11 is 11, and then we'll have plus 3 root 11, plus 3 root 11, and then plus 9, divided by root 11 is 11, and then there's not going to be any middle terms, but we can show that real quick. 3 root 11, and then minus 3 root 11, and then minus 9, so these middle terms cancel, and we just have to simplify a little bit here. So 11 plus 9 is 20, and then these two combine to 6 root 11, and then the denominator 11 minus 9 is 2, and that actually simplifies a little bit because I could divide these separately because they are divisible by 2. So this would actually be 10 plus 3 root 11, and that is the answer.